We're going to now calculate the pH beyond the equivalence point. So we're going to set this problem up the exact same as the previous one. So I'm going to let you follow along and I'll chime in when it becomes important. So what we should notice here is that at the end of our ice table, when we've reached equilibrium, I now have sodium hydroxide and my sodium acetate. So I know that my sodium acetate can hydrolyze to produce hydroxide ions. However, since it's a weak base, it's going to hydrolyze to such a little extent that we can basically ignore it. The amount of hydroxide ions that's going to be produced from the remaining sodium hydroxide is going to be far greater than the amount that's going to result from acetate ion hydrolyzing. So we can assume that the final hydroxide ion concentration is solely coming from sodium hydroxide. We can ignore the minimal amount that is going to come from the hydrolysis of acetate ion. So we're just going to take the negative log of 0.00909 molar to get our POH, and then 14 minus that answer to get our pH. So if we compare the two curves here for a strong acid, strong base titration versus a weak acid, strong base titration, hopefully we can see some similarities and differences here. So first of all, our initial pH should start out a little bit higher for a weak acid than for our strong acid, assuming we have the same concentrations of each. And that is because our weak acid will only partially ionize. As we add our titrant, we see a slow rise in the pH. The pH should go up slightly at a greater rate for the weak acid than for the strong acid. When we near the equivalence point, we see that drastic rise in the pH. However, that occurs over a shorter range for the weak acid strong base titration. At the equivalence point, the pH is greater for the weak acid strong base titration. For a strong acid strong base titration, the equivalence point is 7. And then it's similar as we add excess sodium hydroxide. And so the implication of this here is when we're choosing an indicator for an endpoint, we want to make sure that we are using the appropriate indicator depending on the situation. So for a strong acid, strong base titration, we can use a greater range of indicators as that drastic rise in pH happens over a greater pH range. For a weak acid, strong base titration, that drastic rise happens over a smaller pH range, so we should be using an indicator that has a pKa somewhere within that steep rise. I will not be creating a video for the next section, weak base strong acid titrations, as it's essentially the reverse situation. So I will invite you to try those on your own and refer to the completed notes posted online if you'd like to check your answers.